So here goes. So I want to graph this logarithm. We just real quick reviewed the definition. You repeated for me already that the logarithm produces a power, and we have already, in fact, graphed this. But the way we graph this is we graphed the related exponential. If you remember in a previous section, you can look this up in your notes. We graphed f of x is equal to 2 to the x power, which was the exponential. And then we graphed the inverse by flip-flopping the x's and the y's. And we came up with the logarithmic graph already. You just didn't know that it was called a logarithm at that time. Okay, that's how sneaky I am. So now what we're going to do is we're going to actually create it from this logarithm. So I'm going to create my XY table. This probably won't be the last time I ask you today. And if you're sick of me asking it, that's good. That means you're just starting to learn it. The logarithm always produces a what? It's the power. That's always the output. So the reason I mention that here is my x values that I pick. Anytime you graph a logarithm, you should pick things that are powers of the base. Okay, so pick powers of the base, whatever it is. In this case, this problem that we're getting ready to graph, it's base 2. So I'm going to pick x values that are powers of 2. When you do your first problem, you're going to graph log base 3. You're going to pick x values that are powers of 3. So what I mean by that is, so 8 is 2 times 2 times 2, and 4 is 2 times 2, and 2 is just 2. Then I'm always going to pick 1, because anything to the 0 power gives me 1. And then I will pick 1 that's going to give me a negative exponent. I'm going to pick 1/2. We can go further, we can go further if you want to do 1/4 as well, but I'm going to be quite satisfied with this. Okay, so I'm just going to write this out. You don't have to write this whole thing out every time, but when I plug 8 in, I've got log base 2 of 8. You've already told me twice today that the logarithm produces a power. So here's the question. This is how you interact with the logarithms. My base is 2. 2 to what power is going to give me 8? 3, right? So the logarithm produces a power. 2 to the 3rd power is 8. I'm going to put in 4. Log base 2 of 4. So again, same question. My base is 2. 2 to what power is going to give me 4? 2. Yeah, excellent. When I put 2 in, log base 2 of 2. 2 to what power gives me 2? 1. Log base 2 of 1. I'm sorry that it's a little messy. I should probably make some extra room here. Hopefully you forgive me. 2 to what power gives me 1? 0. And then last but not least, 2 to what power gives me 1/2? -1. We've flipped the base, so the exponent is negative. Notice in each case, the logarithm produced the exponent. And these values should look fairly familiar. If you go back again in your notes to section 2, when we first started graphing the inverse, okay, this is just what we got when we flip-flop the values of the exponential graph. So now I will go ahead and I'll plot the values. I've got 8 and then 3. So I'm going to make a dot right there at 8, 3. I've got 4 and 2. I've got 2 and 1, 1 and 0, and then 1/2 and -1. And so this is my logarithmic graph. If you remember, and if you don't, I'm telling you now, the y-axis is a vertical asymptote. So I'm just going to put the letters VA right there for vertical asymptote. And that's our graph. Just giving you a second to catch up to all those dots, and then I'm going to ask you the 2 questions at the bottom. What's the domain and what's the range? So the domain of this, what's the furthest left this goes? What's the left-hand boundary? 0. Fantastic. Love it. How far right does this go? Yes, it does. Infinity. Beautiful. I'm going to put a parenthesis at 0 because that's an asymptote. It never touches or goes through the y-axis. What's the range? How far down does this go? -infinity. Yep. And how far up does this go? Yeah, beautiful. Well said. Awesome. Again, I'm not trying to oversimplify this because I do know this is very difficult stuff. So I want us to keep practicing. There's our basic logarithm graph. And so what I would like you to do, I'm going to give you a couple minutes. I'm going to pause the video just so that we'll keep this a little shorter. So if you're doing this on the video, pause yourself. Go ahead and do exercise 1 and graph the log base 3. I'm going to follow my own advice here. And so I'm going to pick my values. And so help me out. What are values that are powers of 3 that are going to be helpful to me here? 9's great. 6 is not a power of 3, so that's not going to help me too much. 3, and then 1, and then I'm going to do a -1, so 1/3. 27 is also a power of 3, but 27 doesn't fit on my grid, so it's not going to do me much good right here. So because I don't have a whole lot of room, I'm just going to write this down below. So if I do log base 3 of 9, remember logarithm always produces the exponent or the power. So 3 to what power is 9? Yep. And then log base 3 of 3 is the next one. So 3 to what power is 3? Log base 3 of 1, 3 to what power is 1? In fact, any logarithm, anytime you're taking the logarithm of 1, doesn't matter the base, it's always going to be 0 because anything to the 0 power is going to give us 1. And then finally, log base 3 of 1/3. And what's the exponent there? -1. Are you starting to track on this? Okay, I'm going to ask you to do this very same thing on the test. I'm going to have you do a basic graph. You're going to make the table for me, hoping that it'll go nice and smooth for you. That's my hope. And so 9 and 2, and then we've got 3 and 1, and 1 and 0, and then 1/3 and -1. So here's my graph. Notice it increases even slower than the previous one. That's the thing about logarithms. That's one of their uses, is they can help you understand exponential growth by slowing it down a little bit. There's some applications that you might see. The domain and the range are going to stay the same. Okay, so this, again, we're just talking about our basic graphs. So each of these is just a basic graph. We're just changing the base, but each of the basic graphs, the domain and the range are going to stay the same. So I've got one more for you just because I want you to practice this. So go ahead and do exercise 2. I don't know why there's an E there, probably just because I can't type. So that E means nothing. There's no special secret there. So exercise 2, graph log base 5 of x. I'm going to make my table, hoping you did this same thing. I'm going to pick x values that are powers of my base. In this case, it's base 5. I'm really limited with base 5 because you could, of course, put in x is 25. That's not going to do you much good as far as graphing is concerned unless you have a bigger piece of paper. So I'm going to use 5, and I'm going to use 1, and I'm going to use 1/5. So just for fun's sake, if I put in 25, the log base 5 of 25, 5 to what power is 25? That's 2. Okay, 5 to what power is 5? That's going to be 1. 5 to what power is 1? That's going to be 0. And then 5 to what power is a fifth? That's -1. So the 3 points that I have there that can help you with my graph are 5, 1, 1, 0, a fifth, so just a smidge, and -1. And so it looks something like this. It's growing really, really slow. And there it is. Domain and range, same thing. So one thing that I'd like you to see on each of these is that the domain of my basic graph, so the domain of the basic graph so if I have log any base a of x, the domain of that is going to be, my x's are going to be greater than 0. You can see that in each of the 3 graphs that we've just done. So in other words, that's 0 to infinity. The reason I mention that is because now we're going to turn the page and we're going to say, okay, well, what happens when I start doing different things to the basic graph? So I'm going to flip to page 2 of our little sheet. Domain of the basic logarithm, the log base a of x, x has to be bigger than 0. You can't take the logarithm of 0. You can't take the logarithm of anything negative. So I flip the page. Well, now, my example is I've got log base 2 of x minus 1. So now instead of a plain old x in there, I've got x minus 1. But here's the thing. Whatever I'm taking the log of, what we just saw on the previous page, I'm going to circle it. Whatever I'm taking the log of has to be bigger than 0. No choice. So that means in this case, whatever x minus 1, whatever output I get from x minus 1 has to be greater than 0. And this is always the procedure when I ask you, and I'm going to find the domain of this logarithm. You're just going to take whatever you're taking the log of and say it has to be bigger than 0. I cannot take the logarithm of a negative. I cannot take the logarithm of 0. Has to be bigger than 0. So in this case, I picked myself, because I'm lazy, a nice, easy example. I'm going to add 1 to both sides. And in this case, x has to be bigger than 1. If I pick something smaller than 1, then I'm going to violate the domain of the logarithm. I'm going to get a negative, or I'm going to get 0. Writing this as an interval, since all my x values are bigger than 1, that means 1 is the low end of the interval, and infinity is going to be the upper end of the interval. And there we go. There's my domain of example 2. All right, well, I've created a problem that's a little bit more of a challenge for you. So I would like you to do exercise 3. What I'm going to do is I'm going to, since I've asked you to find the domain, I'm going to take what I'm grabbing the log of there, the 5 minus 2x, and I'm going to say, okay, 5 minus 2x has to be bigger than 0. Can't be negative, can't be equal to 0. And so I'm going to first subtract 5 from both sides. You get negative 2x is greater than negative 5. I'm going to divide both sides by negative 2 and get x, and negative 5 divided by negative 2 is 5 over 2. And just a real quick reminder from our first day of class, what do I have to do when I divide both sides of an inequality by a negative? Got to flip that sign so it becomes a less than sign. So now my domain is all values less than 5/2 or 2.5 if you use the decimal. And so since everything is less than that, 5/2 is now the upper side of the domain, and the lower side is -infinity. And there's my domain. All right, exercise 4 is a challenge problem. Okay, you're going to see one or two like this in the homework. So I want you to see how far can you get. What's the domain when I have the absolute value of 3x minus 7 that I'm taking the logarithm of? So this one is a challenge, so don't beat yourself up if you don't get it right straight away, but give it a try. All right, so this one, I've given you an absolute value. So we talked about absolute value. We talked about absolute value inequalities a while ago. That'll be something we'll review on our final exam review day. But just here's the first question. What kind of value does absolute value always produce? Always produces positive, right? So in general, 3x minus 7, when I take the absolute value, I'm almost always going to get something bigger than 0. There's only one value that I have to be careful of here. Can I have equal to 0? No. So let me just summarize what I've said, because I know this is a difficult thought little experiment here. So the absolute value always produces a positive output, except for when it is equal to 0. So the value that we have to exclude is the value that makes that absolute value equal to 0. Okay? Otherwise, we're good to go. So the one that I have to exclude is when is 3x minus 7, when is that equal to 0? Well, I'll add the 7 to both sides, and I get 3x is equal to 7. I'll divide both sides by 3. I get x is 7/3. So for this problem, again, this was a difficult one. It was a challenge. Okay, for this problem, any x value that I plug in is going to be great. It's going to plug in, it's going to produce a positive output, except for 7/3. 7/3 is where it's going to be equal to 0. My domain can never be equal to 0 when I'm considering a logarithm. So I'm going to exclude that. So that means my domain is -infinity to 7/3 union 7/3 to infinity. That's the fancy math way to say you can use any value except for 7/3. Well, I don't want to end on a note of taking away confidence. So we're just, before we finish up with the more graphing, let's go to the last page here. I'm going to give you one more, okay, just because that seems like it was me being mean. So let's find the domain of this. Okay, so one more, find the domain. This is not going to be too much of a big deal, I hope. So f of x is equal to, let's go the log base 6 of something like, it doesn't really matter, 5x minus 2. Okay, so find the domain of that. All right, so again, I dialed it down. This is a very straightforward problem. And so this is going to be, I'm going to take this 5x minus 2 and say, okay, since I'm finding the domain, that has to be bigger than 0. So we add the 2 to both sides. 5x has to be bigger than 2. I'm going to divide by 5. X has to be bigger than 2 over 5. So that as an interval, if all my values are bigger than 2 over 5, that starts as 2 over 5, and then it goes to infinity. And there we go. I'll give you a little forewarning about the test. I want you to do your homework, but if you have a question about this, then next time I'll look at this. So for instance, I put this, being totally forthright with you, I put this as a bonus on the next test. Find the domain of this. I'm not going to do this problem right now. It is on the homework. I don't even bonus problems. They're always, all my problems are always on the homework somewhere. So if we're going to find the domain of this, f of x is equal to something like log base 3, and then something like 4 minus x squared. Reason I like that problem, the reason when you're doing your homework, it's a good thing to do, is because it forces you to do a quadratic inequality, which we talked about in chapter 3 when we dealt with quadratic inequalities. Okay, so remember, you make your number line, and then you find the points where it's 0, and then you test each of the intervals that results. So that's going to be your procedure. So just forewarning you, that's on the homework. If after you've done your homework, if you still don't love that problem, we can talk about it next time. I'm happy to help you through anything that is giving you cause to stumble. Okay, so all right, so let's go back to the second page now. We're going to just do a little bit more with our graphing. So now we've already done our basic graphs. We've already done our log base 2 of x. We've already done our log base 3 of x. We did log base 5 of x. Those are kind of the most basic ones that fit on our grid. So now we're just doing transformations like we do every time we come up with a new basic graph. So what I would like you to do, please, I'm going to give you a couple minutes, 90 seconds or so. I want you to graph log base 2, and in parentheses, there's x plus 2. Okay, so what happens to my basic graph in this instance? So you can see all I've done here is I have just recreated the log base 2 of x graph. So if you flipped over to the front page and reread your table, or if you recreated the table just because you wanted to practice, that's all great. And now what does this plus 2 that's inside parentheses attached to the x, what does it do to my basic graph? Yep, it's going to move the whole thing left 2 units. Fantastic. Well said. So I'm going to move each of my dots. I'm just going to count left 2. So here we go. Left 2 to here, left 2 here, left 2, left 2, and then 1, 2, left 2. I'm also going to move my asymptote. So there it is. And then my graph looks like this. It's the same graph. We haven't stretched it or shrunk it. We have just translated it. So remember, translations don't change the shape of the graph at all. Again, we've been translating since chapter 2. I hope that doesn't look novel to you, because there's going to be a lot of that, especially when we get to the final exam. That's one of the big focuses of the final, is translating all these fun little graphs we've been doing. Okay, exercise 5, same thing, same basic graph, log base 2 graph. And if you got a question, ask it. That's what I'm here for. Okay, so this time the -3 is not in parentheses, so it's outside of the function. So what is this -3 going to do to my graph? Yeah, exactly, down 3. Great job. Okay, down 3. So I'm just going to move each of my points down 3. So 1, 2, 3, boom. 1, 2, 3, and then 1, 2, 3, 1, 2, 3, and then last but not least, 1, 2, 3. The vertical asymptote's not going to move because we just moved it down instead of left or right. So I'm not going to bother worrying about that. I'm just going to use my y-axis there, and there's my graph that's been moved down 3. We doing okay with this? Okay, I hope if there's one thing you can identify translations at this point in the semester. All right, exercise 6. We're now switching bases. Notice it's log base 3. This time we're doing a couple things to the graph, so have fun. All right, so I've got my log base 3 graph reproduced from page 1. Maybe made a new table. It's good to practice. What is happening to my log base 3 graph according to the transformations that are done here? Okay, the -3, so let's go in the positive x direction. So we're going right 3, great. And then the +1. Yep, beautiful. Well said. Right 3, up 1. So I'm going to take each of my points, up 1 and right 3. So this first one, up 1, and then I got to do a little guesstimating. 1, 2, 3. Didn't do a great job with the example. I'm sorry. Up 1, 1, 2, 3. Up 1, 1, 2, 3. And then finally, up 1, 1, 2, 3 right there. I'm going to move my vertical asymptote over 3. And so here is the graph, looks something like this, and boom, excellent. I got one more graph for us, and then we're going to finish off our time by doing some review of some of the things we talked about in the past few days, because I know this is a very difficult unit. So exercise 7, the last of our graphs for the day. So in this case, what does that negative out in front of my logarithm, what's going to do to the graph? It's going to flip it. Flip which values? The x values, the y values? The y values, yes. So we're gonna multiply the y values by -1, which you are indeed right. That has the effect of flipping the graph around the x-axis. So this is going to be, instead of a +2, it's going to be a -2. So dot. Instead of a +1, a -1 dot. The 0 is going to stay 0. Instead of a -1, it becomes a +1. So I make a dot, and there's my graph. Nice and decreasing. I don't know if I'm going to, I did it. Good job. There's my graph.